Hello everyone, welcome to Curio Desk. In this video, we will be learning about trigonometry and specifically the trigonometric ratios. Now, the application of trigonometry is in the field of architecture to design and construct buildings and such huge structures, astronomy to calculate the distance between stars or planets. They use a method called the trigonometric parallax. And then in the field of computer science, the sine function, cosine function, etc. are used there. Physics in the study of vectors, in the study of projectile motions, and so many applications of it in the field of engineering also. Okay, now trigonometry, if we are to define it, it is the relationship between the sides and the angles of a triangle. Okay, the sides and angles of the triangles, they have some relationship, and we are going to study that. And trigonometry is about studying that relationship. Okay, and it is applicable in all types of triangles, but here we are just going to study for the right angle triangle only. Okay, so here, okay, so now to denote the relationship between sides and angles, we have some ratios. Okay, they are called trigonometric ratios. They denote the relationship between the sides and the angles of triangle, and we name them by sine, cosine, tangent, cotangent, secant, and cosecant. Okay, in short form, we write sine, cos, tan, cot, sec, and cosec. Okay, sine is when perpendicular is divided by the hypotenuse, then we call that ratio sine. When base is divided by the hypotenuse, we call it cos. When perpendicular is divided by the base, then that ratio is called tan. And these are just opposite of this thing. Okay, tan. I guess here it is. So tan and cot opposite of each other. I mean inverse. 1 over tan is equals to cot, because this is p by b and cot is b by p. And cos is opposite of sec. This is b by h. This is h by b, and sine is opposite of cosec. Okay, this is p by h and this is h by p. Until and unless we don't have an angle of reference, we don't keep an angle here, it is difficult. It is we can't say for certain that this is perpendicular and this is base. So once we come up with an angle, then we can decide which one is our perpendicular and which one is the base. Okay, and to remember this thing, there is a simple thing here. This is called, I think, a mnemonic or something. So some people have curly brown hair turns permanently black. Okay, sine is p by h, cos is b by h, and tan is p by b, perpendicular by base. Okay, and these things are just opposite. So I think let's proceed. Now here, okay, we have a right angle triangle, and we have named this angle as theta. Okay, theta is nothing but like in linear equation we used to see that if we do not know a number, we say that let the number be x. So here we just say let the angle be theta, something like that. It's just a symbol to denote an angle. And here you see, now the perpendicular depends on theta. Okay, perpendicular and base, and the side that is exactly opposite to this theta, to this angle, is perpendicular, and the side that is exactly opposite to this 90-degree is our hypotenuse, and the remaining one is base. Okay, that side that is adjacent to this particular theta is base. Here also, here is our theta, and our perpendicular is going to be this exact opposite side, and this is going to be our hypotenuse, and this one is going to be our base. Now we will calculate the ratios. Okay, now in this first triangle, this is first triangle, so sine theta, if we are to calculate the sine theta, then we have to divide this perpendicular by hypotenuse. Our perpendicular here is xy, and our hypotenuse will be xz. Okay, similarly, cos theta is base by hypotenuse. Our base here is zy, and our hypotenuse is zx, and tan is perpendicular by base, and tan theta here will be perpendicular xy, and this is zy or zy. Cot is base by perpendicular. Okay, these things are easy now. This is just opposite, inverse of each other, and this one is hypotenuse by base, zx by zy, and cosec theta is xz by xy. Okay, and in the second triangle, if we calculate sine, then here perpendicular is going to be zy. Okay, zy is going to be our perpendicular because our theta is here. So perpendicular by hypotenuse is xz. Okay, cos theta is xy is base, and zx is hypotenuse. Tan theta is perpendicular is zy, and base is xy. Okay, and these things are there. Okay, so now let us determine the values of all the trigonometric ratios from the given figure. Okay, here our hypotenuse is not given, so we will firstly calculate the hypotenuse using the Pythagoras theorem, and we will use this theorem: AC squared hypotenuse squared is equals to base squared plus perpendicular squared, and we just substitute the value. BC is 5 and AB is 12, and 5 squared is 25 plus 12 squared is 144. We add, we get 169. Now AC squared is 169. Now AC is equals to root over 169. We take square root both the sides. Okay. Now AC is equals to this 169 is product of 13 multiplied by 13, and our AC turns out to be 13 centimeter. Now we calculate sine theta. Sine theta is perpendicular. Which one is our perpendicular here? So theta is here. So sine theta perpendicular is here. So AB divided by AC. So 12 by 13. Cos theta will be base divided by hypotenuse, 5 divided by 13. Tan theta will be perpendicular divided by the base, 12 by 5, and cot theta will be BC by AB. Cot is opposite of tan, so inverse, so this is 5 by 12, and sec theta is 13 by 5. Okay, this is just inverse of cos, and then cosec is equals to 13 hypotenuse divided by perpendicular. Okay, it's fairly simple. And here we have two questions. In one, if tan C is 4 by 3, find the value of sin C, cos C, sin A, cos A, and tan A. So in place of theta, we can write C also. Okay, so here is our theta. We can just denote it by C also, tan C also, and we can remove this thing. So tan C means we need to calculate the ratios when the angle is at C. If I would have said tan A, then we should have considered the angle to be at A. Okay, and then we will accordingly decide the perpendicular. If it were at A, then perpendicular would be here. So we have tan C here, so our perpendicular will be here. Okay, so we can calculate it. It's easy, and there is a hint here in this question number 2. Okay, hint for question number 2. So when you do this addition, so this is going to be there, and now the next step will be you just take LCM for both these things. It will be 5, and we add this one, and you take LCM. This will be 5, 4 minus 3. And then what to do when a fraction is divided by another fraction? That time you keep the top fraction as it is. Top fraction is 7 by 5 as it is, and we just flip this one. This is 1 by 5. We make it 5 by 1, and then you just change this division into multiplication. And then the answers are here. Sin C is 4 by 5 for the first one, and here are the answers, and for the second the answer is 7. Okay, I hope you understood it, and thank you. Do like and subscribe and hit the bell icon. You can like us on Facebook and follow us on Instagram. Thanks a lot.